Hey everyone, hope you're doing well today. In this video, let's talk about writing linear equations, but more specifically, let's practice writing these linear equations when we're given a table of information. Let's take a look at this first table together. Now remember, when we're writing our linear equations, we're going to take the form of y equals, or the dependent variable equals, and we're going to have some number in front, or a coefficient, and that's going to multiply by the x value, and that's going to be this x right over here, and then we're going to add or subtract some number afterwards, and that's going to depend on each equation, right? So just try to keep that in mind for the future. Now, a great way to start writing these linear equations is always to identify where we see 0 in the table. Depending on where the 0 is in the x column, this number that's associated, that's a y value, is going to be, that number here is positive 5, so we know we're going to have y is equal to some number multiplied by x, and because it's a positive 5, we're going to write plus 5 afterwards. At this point, you should look at all of your x values, and if you add 5 to all of them, notice how they equal the y value. That means we don't need to multiply x by any value. Now, by the identity property of multiplication, we can multiply that by 1 so it stays the same. Our final linear equation here is going to be y is equal to 1 times x, or just x, and then we're going to add 5 on afterwards. Go ahead and add plus 5. This would be the linear equation here. Here's a slightly different one. Remember, this is the form that we're looking for our linear equation. And just like the last example, we should look to see where x is equal to 0, because that gives us a major hint in terms of what we are adding in our linear equation. Notice how that's also 0 here. If it's also 0, then we're going to add 0. So we're going to write y is equal to some number that's going to be multiplied by x. We don't know what that is yet. But then afterwards, we're going to go ahead and add 0. So based on that, we know we're not going to add any value. Now, as for figuring out the number that we're multiplying x by, notice how all the x values are getting smaller. Specifically, they're being divided by 3. Now, keep in mind that if we are dividing by 3, that's the same thing as multiplying by 1/3. Based on that, we know that this coefficient is going to be 1/3. We're going to write 1 over 3 multiplied by x, and then we're going to add 0 after that. Let's see what this looks like. We're going to write y is equal to 1/3 times x, or just 1/3 x. This right here should bear a linear equation, and hopefully it makes sense that if you take 1/3 of all the x values, you get the y values. The reason why we're not adding or subtracting anything here is because when x was 0, y was also 0. This right here would be the linear equation. Let's try another one together. Remember, our linear equation is going to take the form of y equals some number times x plus or minus some number. Take a look and see if you can identify when x is equal to 0 in the table. If you see it's right here, great. Based on that, we know this y value is going to be 2 when x is 0. Based on that, we can also say that this positive 2 means we're going to be putting a positive 2 in when we're adding at the end. So we're going to have y is equal to some number multiplied by x, and because it's a positive 2, we're going to write plus 2 at the end here. So we know that at some point we need to add 2 to get all the y values. If that's true, go ahead and take away 2 from all of the y values and see what happens. If we take away 2 over here, 2 minus 2 is 0. If we take away 2 here, 5 minus 2 is equal to 3. If we take away 2 from 8, then that's going to equal 6. If we take away 2 from 11, that's going to equal 9. And if we take away 2 from 14, that's going to get us 12. Looking at the relationship between these numbers now, notice how 4 times 3 is equal to 12, 3 times 3 is equal to 9, 2 times 3 is equal to 6, 1 times 3 is equal to 3, and 0 times 3 is still 0. So times 3 is going to be our pattern here, so we know we're going to multiply x by 3. Our linear equation here is going to be y is equal to 3 times x, or just 3x, and then plus 2 afterwards. There's our linear equation. Here's another. Remember, this is the general form that our linear equations will take. And start off by identifying where x is equal to 0, and that's going to be over here, and when that happens, the y value is going to equal 2, just like in the last example. Based on that, we can go ahead and write our linear equation for what we know so far, and that's going to be the dependent variable equals some number multiplied by x, and because we have a positive 2, we're going to add 2 on afterwards. So if we know we're going to have to eventually add 2 to get our y values, let's go ahead and take away 2 from each of the y values to see if we can identify what's going to multiply by x. So 2 minus 2, that's going to be 0. 5 minus 2, that's going to equal 3. 8 minus 2 is going to equal 6, 11 minus 2 is going to equal 9, and 14 minus 2 is going to equal 12. So I guess the question is how do we get from each of our x values to each of our y values? All right, so starting off, 8 times some number has to equal 12, and 6 times some number has to equal 9, and 4 times each number is going to have to equal 6, 2 times something is 3, and this one's not really as helpful, but 0 times something is equal to 0. Now, again, 8 times some number equals 12, so at this point you've learned one-step equations, so that means 8 times some number is equal to 12. Right? And if you want to figure out what that sum number is, what we can do is go ahead and divide both sides by 8 using the division property of equality, and you're going to notice that 12 divided by 8 is going to be 1.5 or 1.5. Now, while I used 8 and the 12 from the table, you can also use a different one. So we can say to the one right next to it that 6 times some number had to equal 9, right? And if we go ahead and divide both sides by 6, then 9 divided by 6 means that x here will also equal 1.5. If you're not sure, you can go ahead and double check that, but I promise it's true that each time they're going to multiply these x values by 1.5. So based on that, we know that this coefficient is going to be 1.5, and that's what we're going to multiply each of our x values by each time. So simplifying this a little bit, we know our linear equation is going to be y is equal to 1.5 times x, or just 1.5x, and then afterwards we're going to add on 2 as our constant. This right here would be our linear equation. All right, here's one final one, and let's see if you can identify why this one might be a little bit more tricky than the others. Don't forget though that we're still going to be using this general form for linear equations. If you look closely and realize that there's no x value that equals 0, then good job on that, because that makes it a little bit more difficult for us to find out what we're adding and subtracting first, right? But have no fear, keep in mind that linear equations have this same property that we have a pattern. So notice how we take away 6 as we go across each time here. Take away 6, we take away another 6, we take away another 6. So if this is the case, then if we want to know what would x be, when it's 0, or what y is going to be, we need to just subtract 6 again. So what we can do here is basically create another data point here, because remember, linear equations go on forever. So I'm going to write it on the right side, but essentially I would be sticking this in on the left side of the table, where we could also continue the same pattern, right? So eventually x will equal 0 if you go one more to the left here. Now, as for the y values, notice how those are going down by 4 as we move to the left, right? So it's really important that you understand that for linear equations, we always have this same idea where we have a constant rate of change, right? So just like earlier, if we go one more to the left here, if you have 3 and you take away 4, you would end up at -1, right? So when x is 0, y would be -1. Now, it wasn't in the table, but that's something that you can easily figure out if you continue the pattern that we see for linear equations. So now that we've identified here that x is 0, we know that this number right here is going to be what we're adding or subtracting on our linear equation. So we can say y is going to be equal to some number multiplied by x, and because it's a -1, we're going to be subtracting 1 in our linear equation. If we know we're eventually going to have to subtract 1 to find out the y values, then let's go ahead and add 1 and figure out what they were before that. So 3 plus 1, that's going to equal 4, 7 plus 1, that's going to equal 8, 11 plus 1 is going to equal 12, 15 plus 1 is going to equal 16, and 19 plus 1 is going to equal 20. Remember, we're eventually going to need these numbers because we'll have to take away 1 to get each of those y values of 3, 7, 11, 15, and 19. So the question you have to ask yourself now is, how does 30 become 20? How does 24 become 16, 18 become 12, 12 become 8, and 6 become 4? There must be some relationship there. Starting on the left side there, we know that 6 times some number has to equal 4, right? And if you want to figure out what that number is, we can go ahead and divide both sides by 6 and find out that x is going to equal 4/6, but that simplifies down to 2/3, right? So that number you would multiply is 2/3. And just for good measure, let's try that one in the middle where we see 18 for x. 18 times some number has to equal 12, right? And it's got to be the same pattern, so we got to make sure this just works out as well. Otherwise, something's going to be strange. And so we go ahead and get x to the left. And it turns out that 12 over 18, if you divide them both by 6, you end up with 2/3 as well. And so just like that, we figured out that 2/3 is the number that we need to multiply each of the x values by each time. If you multiply 6 by 2/3, you're going to get this 4, and then when you take away 1, you're going to get this 3. If you multiply this 12 by 2/3, you're going to get 8, and taking away 1, you're going to get 7. Again, one more time, just for good measure, if you take this 18 and you multiply by that 2/3 we just figured out, you're going to get 12, and if you take away the 1, you're going to get 11. So that makes me convinced, and hopefully I've convinced you, that our linear equation is going to be y is equal to 2/3 times all the x numbers, and then we're going to take away 1. This right here would be the linear equation that matches this table. So hopefully you found this video helpful in understanding how to create these or write these linear equations a little bit easier when you're given a table by using these patterns. As always, keep up the great work, and I'll see you in the next one.